I'm Piotr. I'm here to tell you a little bit about building agentic AI frameworks and also a little bit about Go. So I have two purposes for this talk. First is to introduce you to AI agents. Second is to present Go as a viable alternative in building production-ready AI-powered applications. So let me just start with a quote from Sundar Pichai, Google CEO, obviously. He got the timing wrong here, but he said that by 2024, AI will power 60% of personal device interactions, with Gen Z adopting AI agents as their preferred method of interaction. I think that still holds. It's just the timing so by 2024, that didn't happen yet, but I believe it will happen. So let's talk about what are AI agents. So we can think about them as just autonomous problem solvers that have access to some kind of perception. It can be a user input, like in chatbox. It can be some kind of external APIs. It can be streaming input. It can be vision. So some kind of input, and the agent has a power of decision making. So this is where obviously our LLMs come in handy. But what's important with AI agents is that they can take action. They are autonomous. They can self-reflect. So if they make an error or some system isn't working, they can resume or take another appropriate action. And they're goal-oriented. So you might ask, how is this different from just LLM with tools? And I have to admit, the line is very blurry right now. In the literature, when you read sometimes about AI agents, sometimes it feels like it's just LLM with tools, but in very general way, AI agent has much better planning. It can work towards the goal in steps. Yeah, it includes long-term memory, and most important, it can interact with the environment. Whereas LM with tools, it's just LM with tools with memory typically limited to the conversation itself, and it works in a reactive way. So right now, I feel like when we're talking about agentic AI, for everyone's mind, it just comes that Python is the way, and I also agree with that. But I wanted to present you another alternative, because when you think about some problems that might arise when your application that you're building is getting very big, and scalability issues start to arise, and the Python is getting more and more complicated. So I wanted to introduce you to Go programming language. It's a language developed at Google, and at first it was built to serve their own needs. So as you might think, the scale, the concurrency, it's supposed to be easy to learn, so new programmers, when they come to Google, can pick it up very quickly. And it's right now it's really known for its simplicity, and kind of focus on practical software engineering. You might use some software that is developed in Go already. From the biggest one is probably Kubernetes and Docker. From AI world, you might know an application called Olama, which is fully built in Go. But Go is really known for being really good for systems, for like networking and distributed systems programming. And what comes to my mind is performance, concurrency, and ease of deployment. Performance, because it's a compiled language, just like C, C++. Concurrency, because it has really easy access to concurrent workflows. So by using things like Go routines, which you might know from other languages like green threads or coroutines, and ease of deployment. In the end, it's only a single library. It's statically linked. So if you compile a binary or cross-compile a binary on your Mac with just one command, you can just copy it into your Linux server and it will work 100%. And it has a cute mascot, as you can see on the left. So I've listed some of the advantages in context of agents. As you might think, the bigger the system with agents you're building, the low latency and performance will play a big role. Also, like I mentioned, concurrency and parallelism are made easy in Go. There is no global interpreter lock like in Python. It doesn't. You can literally spawn millions of Go routines on a single computer that can handle hundreds of thousands of users, for example, HTTP users. Reliability and stability, that speaks for itself. I spoke a bit about deployment and scalability, but in my opinion, the most powerful thing is the standard library, and that it has it's literally batteries included. But in the same way, it's very easy to use. So, coming back to agentic system architecture, is that people often mistake that the better the underlying language model they have in an agent, the better will agent be, and that might be true to some extent, but the true power of agentic systems lies in kind of classic software engineering problems, like state management. I've stated them all. I won't read it, so I won't bore you to death. But coincidentally, this is all those issues are something where Go shines. So I wanted to go through just a simple example app, so you can see some code written in Go. Also, I decided not to use any ready framework because I just wanted to show you that a agent, in principle, it's not that complicated. For us to define a agent, we need basically three parts. The brain, so right in this point of time, this large language model. We need some tool set. So this is just a set of tools that we're going to use, and we need some memory. On the right, you can see 4 interfaces defined, and interface in Go is a contract that if some structure implements, let's say, generate text, it is an LLM that is called duck typing. So if something squawks and walks like a duck, that means it's a duck. So so you can see I defined so LLM speaks for itself. Its generate method. And that's what we need to fulfill to satisfy this interface. Sorry. We have a tool set which hold a lot of tools, and it has two methods: get descriptions for all the tools that the agent is holding, and also execute the tool itself. The tool itself, it's fairly similar to the tool set, and memory, it's super easy. It's just save and recall. Here is a full implementation for one of the LLMs, which is new Sonnet 3.7. You can see that, well, I used the Anthropic library to interact with it, but the code is very concise, and we create a structure that holds required dependencies, and we just implement the method that we talked about. So that means that the Sonnet 3.7 is implementing the LLM service. Similar thing with tools. So we have to implement just two methods: description, and this description is not for humans. It's for LLM itself. It just describes the tool itself, and you can see that this is tool for code execution. So I implemented it in very easy way. I'm just calling Docker with a Python image and passing the script. So you know, I just didn't want to execute it locally because LLM could do something funky and just break my computer. Not that it would do that, but there's a possibility. So to create an agent, we can just tie it all together. So we have our LLM, we have our memory, we have our toolset, and the description that we're gonna talk about a bit later. What I left out is memory implementation. Really nothing to show there because memory, you know, save and recall. This is just in-memory based implementation, and some glue code that is registering a tool in a toolbox and that kind of stuff. It's just adding to the slice. I found out through experimentation that the prompting strategy for a agent works really well when it's implemented as a React prompting. That means that the prompt is running in a loop, and it has basically 3 places to fill. Goal, which is user input, tools, which are the description of the tools that we have available, and observation. And observation is something that the LLM is filling in basically itself. So when a tool is executed, its output is being put into observation, the loop runs again, and it decides if it needs more tools or if it's gonna answer us. I'm sure that at this point you've read it all, but we're just asking LLM to provide us with a list of tools that we need to use to accomplish the task with required arguments. When it's ready to answer the question to the user, it just responds with final answer, and some prompting to ensure that it behaves as we want. I mentioned that here in the agent we have this description, and this is for a purpose, that we can make another agent a sub-agent. So it can fulfill the tool interface. So you can think about it as there's a manager that have sub-agents, workers, each holding different set of skills. Let's say social media manager that interacts with Twitter and Facebook. There's communications manager that deals with mails, and so on and so on. So we can have different sub-agents, and by just implementing those two methods, we're giving this opportunity. Obviously, this is a very simple code on purpose. And there is a lot to improve. For example, using real structured output as opposed to asking LLM to respond with one per line task with some prefix. But I just didn't want to complicate the code, so I can show you how easy in principle the agents are. And obviously, all good software engineering bits or recommendations, it would be good if they would be implemented, like observability, better logging, circuit breakers. So when LLM is either hallucinating or it's going in a loop, we would need some mechanism to stop it, and so on. So this is a real code. This is not purely written for a presentation. You can see that the simplest use of this code here in a very simple app. You can see that we're taking a prompt that we're passing. It should be from prompt for the agent. Passing through CLI. We're using GPT-4 Turbo, and we have some tools. We have Warsaw Weather, which is I called it a dummy tool because it just responds with a string that it's basically mocked tool. It responds with temperature +7 degrees, I believe. There's a time tool. There's also a Slack client attached to our Slack. Don't worry, it doesn't have access to everything. It has very limited access. And there's also Python interpreter. And as an example, just summarize our agent, which is just new agent, just sub agent. And you can see that we're not even passing the memory to this system, so it won't be able to recall our past interactions. So this is all there is, and you can see it here in action. So here, I don't know if you noticed this, but I've just typed go build, which is a compilation step for Go. And this is literally what it took, maybe a second, to build the whole applications. So here we're passing a prompt that is basically impossible for a regular LLM to solve. And given all our tools, it has to decide which tool it will use. And it decided that it will use Python interpreter with this argument. The argument is code, and yeah, looks all right. It obviously executed okay because it gave us a final result. The second example, you can see check the current weather in Warsaw and raise it to the power of 0.23. So you can see that it has to plan. It has to plan the execution, and this example is kind of funky because it just assumed it will be 7. I don't know how it guessed that, but it wanted to execute the Warsaw weather tool, and then Python interpreter, which this code we're not interested in this code. It went through another loop, and now it knows that it's a 7, so it gave different code, which is interesting too. So yeah, so this is our result, and just to be sure, I checked in the sum multiplication. I checked in a calculator that yeah, this is so true. So another demo is to summarize what's happening on Slack channel regarding AI agents. You can see it had to list all the channels. It has let me just it had to pick the appropriate one. It picked the appropriate one and it summarized it. So as you can see, there's not a lot to build agentic systems from the ground up. That goes also for Python, meaning you don't really need frameworks for agentic systems. And my opinion is that it can be even better suited to the needs that you're solving for. But yeah, I hope that I gave you a good glimpse into what Go is capable of. This is if we were at the point that we need to build a big application that, for example, uses agentic AI. probably we should build a prototype quickly in Python, because the prototyping is still quicker in Python than in Go. But then we should just think if maybe Go would make more sense for us to use in the longer run. Thank you.